Hello everyone. I hope you all are doing fine and well. So I am starting a new series, Advanced Illustrations, Mathematics, and I will be trying to cover all the chapters possible for JEE Advanced. Okay. And the first chapter we are taking is Advanced Illustrations, Quadratic Equations. And let's start with the first illustration. The first illustration is taken from Pathfinder book, and the problem goes as if a comma b are roots of this given equation, then prove that ab is a root of this equation. Now let us try to find a starting point of this question. See, questions like these are very typical. Okay, you need to find the starting point for these questions. Many a times, students are not able to find the correct starting point and then they get twisted in the circle or maybe in the loop of not finding the correct approach. And once you are not able to find the correct approach, you will not able to do this problem. So it is a sort of problem that either you get the start or you will not be even able to touch it. So what are the approaches we can think of? See, we have to do something with this a multiplied with b. So I have to think of a method to generate this ab. If I cannot generate ab, then I would never get something like this form. Okay. They have said that a comma b are roots of this equation. They never said that ab is real, positive, negative, nothing of that sort mentioned. It is just said that a comma b are roots of the given equation. Okay. Now, what I can think of for a times b, that one method could be in my back mind is that I put a and b in the equation and multiply it. So let me show you. One thing that could be thought is that we can write a to the power 4 plus a cube equal to 1 and b to the power 4 plus b cube equal to 1. We then multiply both these equations and generate the AB terms. But there are many problems with this approach. The first problem in itself is that this will not generate a to the power 6 into b to the power 6. Let's say if you start by 1 into 2, then you will not be able to generate a to the power 6 into b to the power 6. Now since we will not be able to generate a to the power 6 times b to the power 6, so it looks a dubious move. The other approach should be reducing it. So we have a to the power 4 like equal to 1 minus a cube, and then I multiply it with a, so I get a to the power 5 as a minus a to the power 4, then put it here and continue. But then it becomes a lengthy approach, and it is not necessary that you will get an equation of this form only. Okay, because you will I believe that a trinomial, so it is again difficult to deal with. So generating AB like this is not a good option. Like directly multiplying the equations is not a good option. So what could be the other option for A times B? Hmm. The other option, which looks uh, easy to figure out also, is the product of the roots. Let's say that C comma D are the other two roots. C comma D are the other two roots. Now, if C comma D are the other two roots, then by beta's relation. By beta's relation. By beta's relation, we have ABCD, that is A into B into C into D equal to minus 1. Right? This was the given equation. Okay, let me write down the equation also. The equation is, let's write it down here, x to the power 6 plus x to the power 4 plus x to the, no, sorry, x to the power 4 plus x cube minus 1 equal to 0. This is the equation of whose roots are given to us. So by beta's relation we have ABCD equal to minus 1. Now we want only AB. So let's eliminate CD from here. So we can write CD equal to minus 1 by AB. But this is also not uh, like we now have only CD. But what we want is AB. So we need all the equation sizes. So let us write down all the beta's relation. So we start off with A plus, or we start off with the ones dealing with the products, and let's see what we need. Okay, let's go step by step. So this is how we develop intuition on how to start solving a problem. My first intuition was that I need AB. So I started it off with ABCD. Now I use all the beta's relation in which I will have an AB in it. So the next beta's relation I can think of is product of the roots taken 2 and 3 at a time respectively. So we can see that both of them are 0. Sum of product of roots taken 2 at a time and 3 at a time, both are 0. So this is again telling me that my intuition is going in the right direction. So let's continue with it. So now I have the equation AB plus AC plus AD plus BC plus BD plus CD equal to 0. Moreover, I have ABC plus ABD plus BCD, ABC plus ABD plus ACD plus BCD. That is also equal to 0. Okay. So we have that CD is equal to minus 1 by AB. So let us try to use it. So we take common from here AB and this gives us a C plus D, and from here we take common CD and this will give us A plus B. So this is equal to 0, right? Now I can substitute CD equal to minus 1 by AB. I have this relation CD equal to minus 1 by AB. So I will use it here and I will have AB into C plus D minus A plus B upon AB equal to 0. Okay, I have AB into C plus D minus A plus B upon AB equal to 0. Now, now what? Now I am getting a C plus D and a plus B. So I think this is the right time to invoke the relation of, this is the right time to invoke the relations between A plus B and C plus D. So that can be done best by A plus B plus C plus D equal to minus 1. Again the beta's relation. So by beta's relation we also have A plus B plus C plus D equal to minus 1. And now what we will do moreover, that we will consider A plus B in one bracket and C plus D in the other bracket. Why? Because we have C plus D here in one side and A plus B on the other side, right? So we consider it in this equation also like that only. Alright. Now let us try to do something with these equation also. Like the equation given us in the first equation, right? So from the first equation, I can see that I have AB and CD. So I will take them all together. So I have AB plus CD and CD can be written as minus 1 by AB. Now the rest I am having is A times C plus D plus B times C plus D, and this is equal to 0. Okay, what I did, AB and this CD substituted minus 1 by AB. I took an A common from here and A times C plus D, B common from here plus B times C plus D. So now I can take C plus D common and I will finally have AB minus 1 by AB. This will be equal to minus of A plus B into C plus D. Alright. Now I have something really good for me. What, let me tell you. I have two equations in A plus B and C plus D involving AB, and I have one equation for A plus B and C plus D in a constant. So let me write them down all together. So I have three equations. The first one is A plus B plus C plus D equal to minus 1. The second one is AB into C plus D equal to A plus B upon AB. And the third equation as AB minus 1 by AB minus 1 by AB equal to minus of A plus B into C plus D. So all I have to do is eliminate A plus B and C plus D, and now this is very intuitive. Now this is really very intuitive because what I need to do is first I will substitute A plus B in terms of C plus D in this equation, and then I will obtain C plus D, and as soon as I obtain C plus D I will have my A plus B. So I have A plus B equal to, let us say this is my equation 1, this has equation 2, and this has equation 3. Okay. So from equation 2 we have A plus B equal to AB whole squared, AB whole squared into C plus D. Alright. We have A plus B equal to AB whole square into C plus D. And we have A plus B plus C plus D equal to minus 1. So we put it there. So we have c plus d into a beta whole square plus c plus d equal to minus 1. So from here I will have c plus d common and 1 plus ab whole square. This is equal to minus 1. So finally I have c plus d equal to minus 1 upon 1 plus ab whole square. C plus d equal to minus 1 upon 1 plus ab whole square. Now what I need is a plus b. So a plus b will be a plus b is equal to we had here where a plus b equal to ab whole square into c plus d, so that is equal to minus of ab whole square upon 1 plus ab whole square. Now everything is sorted, everything is perfect. I have got a plus b and c plus d in terms of ab, and life is beautiful now. Why? Because I just now need to substitute a plus b and c plus d in my third equation, and that will not be a difficult task at all, right? So let us do the substitution wala part. Are you all ready? So we will have substitution ab minus 1 by ab, that is equal to minus of a plus b into c plus d. So this becomes minus of a plus b into c plus d will be minus ab whole squared upon 1 plus ab square का whole square. Right? So all in all, now we will be having, let us do some more simplifications. So now we have ab square minus 1 upon ab, and this is equal to ab whole square upon 1 plus ab to the power 4 plus 2ab square. So now we will do some rearrangements. Okay. Alright. Cross multiplying. Let's see what we will get. So we have AB whole cube equal to AB to the power 4 plus 2 times AB square plus 1 1 minute. AB to the power 4 plus 1 multiplied with अरे यार ये ब्रैकेट्स बनाना ना बड़ी मुश्किल काम है यार. ठीक है. So this thing multiplied with AB whole square minus 1. AB whole square minus 1. So now we do the multiplication wala part, the calculation wala part. So this becomes, from here we have an AB to the power of 6, okay, minus AB to the power of 4 plus 2AB to the power of 4 minus 2AB square, okay, plus AB square minus 1. So we will be having a minus here. So we will have minus of AB whole cube, minus of AB whole cube is equal to AB to the power 6 plus AB to the power of 4 minus AB square minus 1. So now we have AB to the power 6 plus AB to the power 4 plus AB to the power 3 minus AB square minus 1 equal to 0. And, and, and what we needed to prove, this thing is equal to 0, has a root AB. So this means if I substitute AB equal to x, then I have x to the power 6 plus x to the power 4 plus x cube minus x square minus 1 equal to 0, and hence proof. Hence proved that x equal to AB is the root of this equation. So how beautiful this problem was. Really a beautiful problem on beta's relation generating A into B. This is a very important concept, especially for JEE. They use beta's relation a lot, and like there could have been many variations on this problem, And while solving, I realized a variation. We were actually having a step, if you remember, that let me come to that step. Yeah, this one. We have an equation connecting A and B, that A plus B equal to minus AB square upon 1 plus AB whole square. So they could have asked you to comment on the sign of A plus B if the equation has real roots. These are many popular questions. Like they could have said that suppose that this is given to you, and like AB is a root, it is given to you. Okay, and now you have to comment, or maybe nothing would have been given to you. Like this part was just vanished. They would have just said that if A comma B are real roots of this equation, then the sign of A plus B is like A plus B is positive, negative, 0, what? And they have the whole right to ask that because we are able to generate A plus B here in terms of AB. So this question becomes very important with respect to generating the values. How we generated AB and A plus B. We will see, I guess, a question in future in this series only, where we will be asked to comment on the sign of the coefficients to know or to establish the relation on real roots. So keep this question in mind while solving that problem. Okay, that is very important. So I hope you have understood this question. Now we will move to the next problem. So now let's see the next problem, illustration 2. If Px is a monic cubic polynomial such that P of 1 equal to 2, P of 2 equal to 3, P of 3 equal to 6, find P of 4. Beautiful problem. Let's see what's beautiful in it. Although it's a pretty simple problem if you know how to approach it, but let's see the underlying secret. Okay, let's talk about this problem where it comes from. So it comes from the house of interpolation of polynomials, which is quite a popular topic in engineering mathematics. But the trick is that it can be solved without using interpolation also. Like you do not need Lagrange's interpolation to solve this problem. It can be solved without it also, and therefore it makes this problem an ideal candidate for JEE Advanced. Because firstly, it is using the concept of first year. Secondly, it does not require the concept of first year. It can be solved using basic principles. If Px is a monic cubic polynomial, so monic means that the leading coefficient is 1. Leading coefficient is 1. Mark it in your mathematics vocabulary. Monic means leading coefficient is equal to 1. Now we are given P of 1 equal to 2, P of 2 equal to 3, P of 3 equal to 6. Now you would have seen many such problems becoming popular. These come from the house of pattern remainders, a very popular class of problem where you are given P1, P2, P3, P4. If I would have not set it to be a monic polynomial, then I would have to give you one more value, right? And generally they would be following a pattern. But here you can see that there is no pattern underneath it. So this makes the problem very much interesting. And students often think how to approach, how to start. Like, I don't know if you have ever dealt with this problem, but if you're dealing it with the first time, you will be really confused that how should I start if I don't have the pattern, I don't have the remainder. That's where you will go wrong. You have the remainder, a generalized remainder. So let's see. Too much of talking then. Now let's jump to the solving part. So I have Px, a monic cubic polynomial. So I have been also given that P of 1 is 2, P of 2 is 3, P of 3 is 6. So what I can say is, let us say that I divide Px by x minus 1 into x minus 2 into x minus 3. Okay. I divide Px by x minus 1 into x minus 2 into x minus 3. I divide a cubic by a cubic. So I can expect a remainder whose degree will be at max 2. So I will expect a quadratic remainder. Since degree of remainder is less than degree of divisor, so I will have this thing for sure. So what I can do is I can write Px equal to x minus 1 into x minus 2 into x minus 3. Since it's a monic polynomial, so I multiply it with a 1 here, the constant, plus the remainder that will be ax square plus bx plus c. This is only the difference it is having. So now all I have to do is find the value of A, B, C. So let me put x equal to 1. I have P of 1 equal to A plus B plus C. And that is equal to, what is the value of P of 1? That is 2. P of 2, that is 2A plus 4B plus C. And what is its value? Its value is 3, I guess. And what is P of 3? P of 3 is 9A plus 3B plus C equal to 0, equal to 6. And here it will be 4A and this will be 2B, right? Alright. Now we need to find ABC, solve this system. Let's do it. So let's say this is equation number 1, this is equation number 2, this one is equation number 3. So let's subtract 2 and 1, we will have 2A plus B equal to 1. Subtract 3 and 2, we will have 8A plus B equal to 3. Now subtract these two equations and you will be having 6A equal to 4 equal to 2. So A becomes 1 by 3. So B will become 1 minus 2 by 3, that is B is also coming out to be 1 by 3. And C, A plus B plus C is 2. So 1 by 3 plus 1 by 3 is 2 by 3 and 2 minus 2 by 3 is 4 by 3. So C equal to 4 by 3. Normal solving. 3 variable, 3 equation, linear one, very simple to solve. Solved. Now just put it back. So we have P of x equal to x minus 1 into x minus 2 into x minus 3 plus 1 by 3x square plus 1 by 3x plus 4 by 3. Simply put x equal to 4. So P of 4 will become 3 into 2 into 1, 6 plus 16 by 3 plus 4 by 3 plus 4 by 3. So this becomes equal to 6 plus 24 by 3, which is nothing but 6 plus 8, and the answer to the problem is 14. So the value of P of 4 is 14. So this was a pretty simple problem, but it used a concept which is my favorite, which is JEE's favorite. That degree of remainder is less than degree of divisor. Not JEE's favorite, but Olympiad's favorite. Many such problem keeps appearing in Olympiads. And by the recent trend, JEE is given many Olympiad based problems. So this should be an important one. Okay. Advanced illustrations will contain all those problems which are important by the trend, from the popular books, from the popular concept, from the popular exams. This is what advanced illustrations is. It is meant to form a firm grip on every chapter of mathematics. So this was a pretty simple problem compared to the first one, but it had a concept that what to do when the remainders are not in pattern. So this was not in a pattern, but we solved it, or by assuming a general remainder. That's what we need to do. Okay. So I think we are done with the first video, 2 illustrations. That's it. Ask if you have any doubts in the comment. Don't hesitate. I will answer. Ask it twice, thrice, no problem. Like the video if you loved the content. If you think that these questions are helping you, share it with your friends, your competitors if you want. I would say share it because this will not affect your rank at all, but it will increase the discussion between you two, increasing your conceptual understanding of the problems. Do it once again, do both the problems on your own without seeing the solutions after seeing it once. Okay, I would recommend you not to solve it while seeing or before seeing, but after seeing the solution, solve the problem on your own and see if you are able to reach till the final answer or not. If you stop at any step, then again revisit the solution. Okay, ignore any calculation mistakes if it has or it has crept in. Okay, so let me end this video on the note. Thank you for being patient.